So welcome to my presentation. Thank you very much for taking the time. After having given you some insight about the organization and the activities of MPS Microsystems, I will show you some active solutions that we have developed for the solving of different challenges in optomechanics. I'm Patrick Ruffieux. I'm product manager here at MPS Microsystems, specialized in optics. So firstly, a few words about MPS, the MPS group, a micro precision system. So it's a Swiss-based company located in Switzerland with roughly 400 employees and a turnover of 70 millions. MPS group is part of the Lateral group, the German manufacturer of micromotors. And the MPS group is divided in 4 entities. MPS Watch, which is focused in the development and the manufacturing of watch bearings and gear wheels for the watchmaking industry. MPS Microsystems, located in Vienne, which is focalized on the low friction, the innovation of low friction microsystem and the manufacturing of ball screws and linear bearings. MPS Precimed, which is focused on in the design, the development and the manufacturing of orthopedic instruments. And MPS Décolletage, which is manufacturing high precision parts for like connectors for other industry sectors. So the strengths of MPS Microsystem is to provide innovative, custom-built, miniaturized systems. So MPS, as you can see here, is acting in different markets. A wide range of markets, like in the medical, optics and photonics, automation, aerospace and defense, and in science as well. Now, I would like to focus on different solutions that have been realized at MPS Microsystems to solve optomechanical challenge. I will start with the multiple lens linear actuator that you can see here on the right part of the screen of the slide. This is a perfect example of a very miniaturized system. The length of the device is 4 centimeters and the lateral dimensions are 2 centimeters. So it has roughly the volume of a matchbox. It's a four lens actuator. So you have one carriage here, one here, and 2 others here. It's driven by 6 millimeter diameter Fowler stepper motors with miniature ball bearings here mounted on 2 millimeter in diameter rods. So this device has been developed for beam shaping application, and it has been thought and created, I mean, in the way to design a scalable system. So from this device, from this mechanical technology, we created a scaled-up device here, which is a 2-lens actuator, a high-precision zoom mechanism. You have one carriage here, one carriage here. So the same structure based on our ball bearings on rods here, with 2 brushless Fowler motors here. And in this example, we had to face another issue than the miniaturization. It was the fact that it had to work in a really highly vibrating environment. So this is laser beam shaping for guiding systems in defense applications, for laser guidance system in defense application. And we had to face the repeatabilities in positioning below 10 microns and lateral deviations below 5 microns. It was developed for airborne application, so we decided to create the whole device, I mean the frame of the device here, in a single block to ensure the best stiffness to this device and be able to have a stable and smooth movement of the lenses, even in this particular environment. Now I would like to introduce a new concept, totally different from the previous one. It's this linear stage actuator for lateral displacement of lenses. So you have, it was developed for freeform type of lenses, like Alvarez ones. So you have one lens on the top here and one lens on the bottom. It's two parts. And with a lateral displacement of each lenses, you can change the focal length of the system and make focalization at different positions. So it was developed for microscopy application, imaging applications. The device here, the mechanical concept is totally different. It's based on flexible structures here. It's a tube bridge configuration to ensure a perfect displacement of the lenses here, lateral one, over strokes of 2.5 millimeters, and the resolution below 2 microns. We have also a really low lateral displacement. It's below 5 microns again. The system is driven by two follower motors here, linked to lead screw here, to ensure no backlash to the system. The last example that I want to share with you today, it's a typical application in science. It's a fiber positioner for astronomical observation. So it's a fiber positioning system. It's based on a SCARA type geometry. So you have two rotational stages here, one here, one here. And the second one is off axis compared to the first one. So by applying different angle on moving the different stages here, you can address different position in the plane here, and we can achieve positioning accuracy of the end of the fiber, which actually goes here in the system and goes out here. So this is the end position of the fiber, and we can achieve positioning accuracy below 10 microns. The main challenge was the integration of everything. I mean, the motors, the gearbox, and the rotational stages here within a diameter of nearly 1 centimeter. This is in the purpose of having higher resolution when you put side by side all the different positioners at the focal plate of the telescope. The application is to collect the light from stars and to make a spectrum analysis of the starlight. So just to summarize, the customization, the reliability, and the precision is the core business of MPS Microsystems. And I hope that all the different devices that I have presented here could show you the capabilities and the adaptation of MPS to different challenges that are commonly faced by industries.